Hello and welcome to Keystone Tutoring. Today we'll be talking about special case differentiation. So if you watched the previous episode on the product, quotient, and chain rule, I talked about there was special cases when we differentiate sine, cos, tan, um, this thing called sec, cosec, exponentials, the natural log, and the log of x. There's some general rules which we use to differentiate these things, and today we'll be going into it. So let's get straight into sine, cos, and tan. So in general, the derivative for sine of x is cos of x. And I've added times, so that's a times here, x, um, x derivative. So whatever is in the x, you also so you derive that, and you usually could say let that equal u of x. So let u of x equal x and differentiate that, and times cos of x times x bar. With the derivative of cos of x is negative sine of x, and then once again we times that whole thing by the derivative of the inner function x. For tan of x, the derivative is sec squared x, and then once again timesing that whole thing by the inner function x. So the rule of thumb is when we find the derivative of sine, cos, and tan, let's say sine, we make it cos and keep the inner part the same as it was originally, but we also times that by the derivative of the inner part, the times the whole thing. So it may sound like a lot of words, but I think once we see some examples, it might become more clear. So first example here is f of x equals sine 3x. So we immediately know there's going to be a cos. And so as we can see here, we have cos 3x, but we have a 3 at the front. Where does this come from? So we let the inner part equal u of x. So we say u of x is equal to 3 of x, and we find that derivative. U dash of x equals 3. So we just times that part, and we times it all by 3, the derivative of the inner part. Awesome. So now we have g of x equals sine 2x squared. Awesome. So this is actually a very interesting case because we can use the chain rule here actually. So what we will do is we'll set g f of x equal to the whole thing, as we can see here. And then we apply f of x. And then f of x would be our inner product, sine 2x. So what's the derivative of sine? We know that to be cos. So cos 2x. But once again, it's like a chain rule within chain rule. We have to times by 2 because the inner derivative of 2x is 2, so times that by 2. And then simply we can also just find the derivative of gf of x, which is simply taking the 2 down, which is just applying it to the 2, taking the 2 down, so it'd be 2 sine 2x. So altogether, it's 2 sine 2x times the inner derivative, 2 cos 2x, which is equal to 4 sine 2x cos 2x. Awesome. So now we'll go on to h of x equals cos squared x. As we know, that will become sine. And then making u of x is equal to 2x squared, we find that to be 4x. Sorry, it would be negative sine. So minus 4x sine 2x squared. And then another simple case with tan 5 of x, making ux equal 5x. So we have 5 and then 5 sec squared 5 of x. So just important note is we always keep the inside bit the same for when we derive it, but it's also important to also derive the times it by the derivative of the inner case. So all of these are, if you picked up on it, are a example of the chain rule. But here we have like a double chain rule in this case because chain rule here, but we have to apply the chain rule again because we've got to times derive the inside of the 2x to times that by 2. So it's pretty much just an example of the chain rule, but just noting these things here. Awesome. So this is pretty much the same thing, but just different ones. So if we have cot of x, its derivative cosec squared. Once again, timesing by the derivative of the inside. Sec of x is sec of x times tan of x. Once again, timesing by the derivative of the inside. Cosec of x is equal to minus cosec x times cot x. So there's a negative here if it's not clear. So let's go to an example. Just do one for this case. We have cos x squared, 3x squared plus 1. General rule, you don't have to do this, but I like to set ux equals 3x squared plus 1. The derivative of that is 6x. And as we saw here, we've got to times that by the derivative. So we have minus 6x, because remember there's a negative. Cosec, the same as the inside, same as the inside. Cot, same as the inside, same as the inside. So general rule here, and yeah, it gets quite repetitive and easy once you use it multiple times. Now in terms of exponentials. So if we have this exponential function here, e times a to the power of x to the n, what we do is this will remain the same. This bit will remain the same, but we have to times by this derivative, and this derivative will be down. So simply that, it's just you can sort of forget about the e and just pretend you're deriving. Let me write this down. Just pretend you're deriving a x to the n, and we know that simply just to be the derivative of that to be, as can be seen here, a stays the same, n comes down, times x to the power of n minus 1, and then we just keep this the same. But let's just go through a worked example. So we have 5 equals e to the minus 2x squared. So once again here, I like to put it in terms of u. So it's like 5e to the u, and then we just find the derivative of u, and then that's quite simple, where u is equal to minus 2x squared. That's just equal to 4x. And then and then we just bring this derivative down and we times that by the 5. So we have 5 times the minus 4x, and then keep this exponential bit the exact same, and we end up with minus 20x e to the minus x squared. So the exponential is the same, just the front changes a little bit. Awesome. So now we're going on to the last topic, natural log of x and log of x. The derivative of ln of x is x over the derivative of x. Very simple formula. And when we have log base a, so it's not a natural log, what happens here is the derivative of log base ax is the derivative of x over x times the natural log of the base, which is a. So let's go into an example. So here we have f of x equals ln 4x squared plus 1. So we see that it's a natural log. So simply we can find u here to be 4x squared plus 1. The derivative of the inside here is just equal to 8x, because remember, anything without a parameter goes to 0. So we have 8x all over the original x here, as we can see, the 4x squared plus 1. Now we'll go into our last example where we don't have a natural log, it's log base 3. Once again, we derive the inside, 2x squared plus 1, the derivative of that is just 4x, bring the 2 down, minus 1, and we get the 4x. And then simply we go back to our formula, derivative of x times x ln of a. So this would be the numerator, 2x squared plus 1 times ln of 3. Awesome. So that comes to the end of today's video. I hope we have provided some clarification, and we look forward to seeing you in the next video, and best of luck with your studies.